Today we are going to use the dot product or the scalar product to find angles. Let's start with two vectors. This is vector A and let's say this is vector B. If you wish to find the angle between the two vectors, you will slide one of the vectors until they are tail to tail. When we want to find the sum of two vectors, remember we put them head to tail. But right now we want the angle between the two, so we put them tail to tail. Let the angle be theta. Now the scalar product or the dot product of the two vectors is defined as length of vector A, length of vector B times cosine of the angle between the two. Now if the angle is obtuse, the answer will be negative. So the dot product can be negative or positive. We can also write down the dot product as AX times BX plus AY times BY plus AZ times BZ. Now we can use these two definitions to find the angle between two vectors. So let's go back to our two vectors. This is vector A and then we have vector B. So first we express the two vectors in terms of their components, and once we write down the dot product in terms of the components, we equate it to length of A times length of B times cosine of the angle between the two, and that will allow us to solve for the angle between the two. Problem number 1. Problem number 1 is where we have a rectangle with sides 2 meters and 4 meters, and the question is find the angle between the two diagonals. And we are going to learn to use vectors to find this angle. Of course, we can do it using geometry, but we're going to use vectors. So let's call this vector A, and this vector, let's say we call it B. And let's say we want the angle between the two vectors. So let's set up a coordinate system. Let's call this our x-axis, and let's call that our y-axis. So you can see right away that vector A is 4i cap plus 2j cap, and vector B is, you have to start at the tail and end up at the tip. So minus 4i cap plus 2j cap, minus 4i cap plus 2j cap. So let's take the dot product of the two. A dot B is equal to AX BX minus 16 plus AY BY 4, that is equal to minus 12. Now we can also write this in terms of length of A. As you can see, the length of A is going to be square root of 4 squared plus 2 squared times the length of B, which is the same thing, 4 squared plus 2 squared, times cos of the angle between the two. Now this is equal to, that is 16 plus 4, 20. Square root of 20 multiplied by square root of 20 is 20 cos theta. So right away we get the answer, and I'm going to write it out here. Cos theta is equal to minus 12 by 20, that is equal to minus 3 by 5. The answer is negative because the angle is obtuse. So the answer to the problem, what is the angle between the diagonals? The answer is cos inverse negative 3 by 5. Now let's go to the next problem. So in this problem, we have a cube and we want to find the angle between two body diagonals. So let's say one body diagonal goes from here to the opposite corner, and the other one, let's say, goes from here to this opposite corner. And let's say we want to find the angle between these two body diagonals. So first thing we're going to do is set up a coordinate system. So let's take, let's say, this edge as lying along the x-axis, and that edge lying along the y-axis, and this along the z-axis, so that our origin is this O, and this is the x-axis, y-axis, and the z-axis. And let's give the body diagonals directions. So let's give this one this direction, and let's give this one this direction. First, let's write down each of the body diagonals in terms of its components. Let's start with this one. And we have to start at the tail and end up at the tip. And let's say each edge of the cube has length A. This is a cube. So starting here at the tail, you move first in the positive y direction. So I have aj cap, and then I move like this, and then I move in the negative x direction minus ai cap, and then I move in the positive k direction plus ak cap. That is one body diagonal. The second body diagonal starts here, and we move, let me use a different color. Let's say this red color. So I start here, and let's say I move down in this direction, in the positive I direction, ai cap, and then I move in the negative y direction, so minus aj cap, right? And then move in the positive z direction plus ak cap. So let's take the dot product of the two. When I take the dot product of the two, it's ay by, that's minus a squared, ax bx minus a squared, az bz plus a squared. So the answer is minus a squared. Again, it's negative because the angle is obtuse. Now this is also equal to the length of one body diagonal, which is square root of 3 times a. A squared plus a squared plus a squared, that is 3a squared. Root of that is root 3a times the length of the other body diagonal, also root 3 times a, times cos of the angle between the two. So that is equal to 3a squared cos theta. So if I compare this formula for the dot product with this formula, I get cos theta is equal to a squared cancels minus 1 upon 3. The answer is cos inverse minus 1 by 3. So this is 109.47 degrees. Does that ring a bell? Does it sound familiar? Think about it. All right, let's go to the third problem. The third problem is a bonus problem. Okay, the third problem is, what is the bond angle in methane? This is methane. So what we are going to do is very simple. We are going to first define each of these vectors from a carbon to hydrogen. We'll call that vector A, and this carbon to this hydrogen, we'll call it vector B, and carbon to the other hydrogen, we'll call it vector C. They're all of the same length, but they point in different directions, so they are different vectors. Now the methane is a particularly symmetric molecule with no bond more important than any other bond and no angle different from any other angle. And because of the symmetry, we have A plus B plus C plus D. Sum of these four vectors pointing away from C is equal to 0. Now you think about this. This follows from the symmetry of the methane molecule. I'll try to give you a quick argument. See if you understand it. Otherwise, you make your own peace with it. Supposing the sum of these four vectors is not 0, then it would be a vector pointing in some direction, right? It would be a vector pointing in some direction, and whatever direction it points at, it will be closer to one of the bonds or closer to two of the bonds, but away from the other bond. Now, no bond can be picked out because all bonds are identical. Therefore, the sum cannot be some finite vector. It has to be 0. Now, we dot this with A, with this sum. A plus B plus C plus D. That is equal to 0. Now, A dot A is A squared, length of the square of A. Now, remember A and B have the same length. So, A dot B is A squared cos of the angle between the two. A dot C, again C and A have the same length. So, A dot C is A squared, same angle cos theta because all the bond angles are identical, plus A dot D is A squared cos theta is equal to 0. So, we get cancelling A squared throughout. Let me get rid of a squared. So I have 1 plus 3 cos theta is equal to 0, and therefore theta is equal to cos inverse minus 1 by 3, which of course we just calculated as 109.47 degrees. So that's it for today, folks. Thank you. See you in the next video.